Hello everyone, how are you all doing tonight? I am so fucking excited right now, y'all. Y'all have no idea. Well, you might have some idea if you check my Twitter. Let me pull up an image. I just got something like a couple minutes before stream. Y'all need to see it. Y'all really need to see it. Oh, so good. I'm so excited. Like, take. Oh, that's big. Wow, Jesus Christ. Y'all, you can probably see it by now, but take a look at this. I've got holographic Lemma sigil cell charms. I am so excited for these. They are just delightful. They're wonderful. I've got 25 of them total, and I'm gonna be giving them to some of the folks who have helped bring Lemma to life, and the rest I'm gonna be selling. So keep an eye on that. I will hopefully have something up for that soon. Yeah, I'm so excited. They look so good, y'all. Like the shininess is just top notch. It's so good. Yeah, tonight I am gonna be learning more Rust. Gonna be very exciting for that. Rust is a really neat language, and I'm really interested in learning it. Just like, even if I don't use it, just it's gonna give me so much to think about for my own languages and such. So yeah. Yeah. Should be good. How about, without further ado, let's go. Right. And let's get on the left side. We've got Rust book. On the right side, we've got, where is it? VS Code. Alright, last time I completed the first 4 chapters of the Rust book, and which covered, getting started, your first interactive program, then programming concepts within Rust, and ownership, and the ownership concepts. So yeah, tonight I am gonna be doing more cool stuff. We're gonna start with structured data. A structure is a custom data type. Yeah, hi Lemma. Hello, Non. Great to see ya. A struct or structure is a custom data type that lets you name and package together multiple related values that make up a meaningful group. If you're familiar with object-oriented language, a struct is like an object's data attributes. In this chapter, we'll compare and contrast tuples with structs. We'll demonstrate how to define and instantiate structs. We'll discuss how to define associated functions, especially the kind of associated functions called methods, to specify behavior associated with a struct type. Structs and enums, discussed in Chapter 6, are the building blocks for creating new types in your program's domain to take full advantage of Rust's compile time checking. Let's go. Structs are similar to tuples, which were discussed in the tuple type section a little while back. Like tuples, the pieces of a struct can be different types. Unlike with tuples, you'll name each piece of data so it's clear what the values mean. As a result of these names, structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the values of an instance. To define a struct, we enter the keyword struct and name the entire struct. Alright, so let's say struct user. The struct's name should describe the significance of the pieces of data being grouped together. Then inside curly brackets, we define the names and types of the pieces of data which we call fields. For example, listing 5.1 shows a struct that stores information about a user account. If cool. Username string, email string, sign in count you 4. Right. I should oh right, I've got Warn Dead code on right now. That's fine. So yeah. To use the struct after we've defined it, we create an instance of that struct by specifying concrete values for each of the fields. Yeah. Let me clear out this previous light code. Oh, glowy light bulb now. Okay. Code actions, got it. I'm good. So. Alright. Stating the name of the struct, alright. Specifying concrete values for each of the fields. So, we will let user1 equals user. Then email string from someone at example.com. Username string from some username 123 active true and sign in count 1 semicolon. All right, don't need the trailing comma. Yeah. All right, don't have to specify the fields in the same order in which we declared them. Yep. Yeah, because the names matter. General template instances fill in that template with particular data to create values of the type. Right, so yeah. You get a specific value from the type. Dot notation, okay? If an instance is mutable, so for example, if I set this as let mute, then I can user1 email equals string from another or someone else. Oh no! Ah! Oh, I realized that sneeze was coming right after it happened. Yeah. I'm good. Yeah. I realized that sneeze was coming just a second too late. Oh well. Okay, so dot notation, good. Entire instance must be mutable. Rust doesn't allow us to mark only certain fields as mutable, okay? You can construct a new instance of the struct as the last expression in the function body to implicitly return that new instance. Yep. So, and build user mail string username string to user mail email username active true sign in count 1. Right? Yeah. Right, makes sense to name the function parameters with the same name as the struct fields, but having to repeat the email and username field names and variables is a bit tedious. Struct had more fields, repeating each name would get even more annoying. Luckily, there's a convenient shorthand. Using the field init shorthand when variables and fields have the same name. Ooh. Alright, so you can just... Okay, that's a cute little system. Yeah. Got it? Yep. Behaves exactly the same. Same, but doesn't have the repetition of email and username. Okay. Here we're creating a new instance of the user struct, which has a field named email. We want to set the email field's value to to the value in the email parameter of the build user function. Because email field and parameter have the same name, we only need to write email rather than email. Okay. Creating instances from other instances with struct update syntax. Alright. So. Alright, yep. Alright, so. What we can do here is let user2 equals user. Then we could just active user1 dot active and everything, or we could just change the one we want to do. So email string from someone else at example.com, then .user1 to copy everything else. Got it. That's neat. I like that. Code and listing start 7 also creates an instance in the user2 that has different values for email but same values for username, active, signing count fields. Yep. That user1 must come last to specify that any remaining fields should get their values from the corresponding fields. We can choose to specify fields for values for as many fields as we want in any order, regardless of the order in structf. Hooray! Struct update syntax. Yeah. It's a like assignment with equals because it moves the data. Okay. Alright. So we can no longer use user1 because this is illegal. Yep. We give user2 new string values for both email and username, that's only used active and signing count values. Yep. Alright. Yep, they implement copy, yeah. Would you be able to, like, and? No. That'd be cool if you could, though. Alright. Okay, so. Yeah, like, that is the. Right, yep. Alright, yeah, if we'd done new string values, yeah. Alright, types implement copy, yeah. And also define structs that look similar to tuples called tuple structs. Yep, tuple structs have the added meaning the struct name provides, but don't have names associated with fields. Rather, they just have the types of the fields. Okay, so. Struct color, yeah. I32, I32, I32. Not struct color, struct. Also, wouldn't you want to use, like, yeah. You'd theoretically just want to use U8 for that, but yeah. Alright. Notice the black and origin values are different types because they're instances of different tuple structs, even though they've got the same sig there. Okay, yeah. Each struct you define is its own type, even though the fields within the struct have the same types. Okay, makes sense. Tuple struct instances behave like tuples. Whoop, I dropped it. I'll get it later, yeah. I've got some, yeah. I got a couple stim toys as a gift, which is very nice. Especially for medicated nights like tonight. Okay. Alright, so each struct you define is its own type. Yep. Even though the fields have the same types. Yep. Yep. Tuple struct instances behave like tuples. You can destructure them. You can use a dot by the index. Okay. Alright, yeah. Unit like structs without any fields. Ooh. Alright, so they behave similar to unit type. They can be in Useful in situations where you need to implement a trait but don't have any data you want to store. Okay. Traits are coming in chapter 10. I wonder if we'll get to that tonight. We'll see. Right, so yeah. Then... Alright, yeah. Makes sense. Yep, struct keyword, name we want, then semicolon. No need for curly brackets or parentheses. And always get an instance of always equal, yep. Using name we defined, yeah. Right, yeah, so that makes sense, okay. Wouldn't need any data to implement that behavior. It's in chapter 10 how to define traits and implement them on any type, including unit-like structs. Ownership of struct data. Own string rather than enter string slice. Deliberate choice because we want instances of the struct to own all of its data and for the data to be valid for as long as the entire struct is valid. Bit sniffly today. Possible for structs to store references to data owned by something else. To do so requires the use of lifetimes. Oh boy. That's chapter 10 as well, okay. Lifetimes ensure the data referenced by a struct is valid for as long as the struct is. Let's say you try to store a reference in a struct without specifying lifetimes like this, which won't work. Yep. Expected and name lifetime parameter. Well, guess we'll be finding out about those later. Yep. Store refs and structs. For now, let's fix errors like these by just using own types, okay. An example program using structs. Let's take a look. So, let's just clear out some of this. Alright, so. Alright. Blank file. Let's see, so to understand when we might want to use structs, let's write a program that calculates the area of a rectangle. We'll start with single vars and then refactor until we're using structs instead. So let's make a new binary project with cargo. Yep, just gonna use the same one because like workspace stuff. Alright, so let width 1 equals 30, let height 1 equals 50. Until n, the area of the rectangle is square pixels, and area width 1, height 1, and up. Then we need to define fun area width 232, height 232 to 232, width times height. Alright. Yeah. I'm not sure I entirely like the, just put a single thing on its own without semicolon to return it syntax, but oh well. I can always just do that instead. Yeah. Yeah. Oh, now you're fine, yeah. Then I can cargo run. Area of the rectangle is 1500 square pixels. Yay! Looks good. If 5.8 works and figures out the area of the rectangle by calling area, we can do better. The width and the height are related to each other because together they describe one rectangle. Issue with this code is evident in the signature of area. Area function is supposed to calculate the area of one rectangle, but the function we wrote has two parameters. They're related, but that's not expressed anywhere in our program. They'd be more readable and more manageable to group width and height together. Alright, let's refactor with tuples. Let rect1 equals 30, 50. Correct. D, not S, then go away. Semicolon, then mention U32, then dimensions dot O times dimensions 1. Alright. Yep, width is tuple index O, height tuple index 1. Yep. Yep, so like this should do the same thing. Yep. Same answer. In one way, this program is better. Tuples let us add a bit of structure, now we're passing it just one argument. But this version is less clear because we don't know what width and height are, so more confusing, you have to index into the parts of the tuple. I can't say, but I want to come say hey and live a little care package. Ooh, thank you, Jasper. Great to see ya, hon. Thank you for the hydrate. Okay. Doesn't matter if we mix up width and height for the area calculation, but if we want to draw the rectangle on screen, it would matter. I have to keep in mind that width is index O, height's index 1. So, structs. So that would be a struct rectangle width U32, height U32, rectangle width 30, height 30, and rectangle rect width and rect height. Oh, that's a wearing light flicker. Should be good, hopefully. Oh, that's why it only says 900. That's supposed to be 30 by 50. I just miswrote it. There, now 1500. Woo! Yeah. Here we've defined a struct and name it rectangle. Inside the curly brackets, we've defined the field as width and height, both of which have type U32. Mainly, we created a particular instance of rectangle with width 30, height 50. There is now one parameter which we've named immutable bar of a struct. Yeah, that should be a borrow. Because if I wanted to, like, print the rectangle after that, that would be illegal. Alright, now it's just a borrow, yeah. That is an important thing in this, I've got to keep in mind, okay, yeah. We want to borrow the struct rather than take ownership. That way main retains and can continue using it. Which is the reason we use and yeah, in the sig and where we call. Area function access width and height, width and height, yep. Signature for now says exactly what we mean. Calculate the area of rectangle using its width and height fields. Yep. Conveys that width and height are related to each other and gives descriptive names to the values rather than using the tuple index values of 0 and 1. Hooray for clarity and readability. Alright, adding useful functionality with derived traits. Because, yeah, so println rect1 is rect1, and you're angry because because rectangle does not implement standard format display, which ain't great, means it can't print it. Alright, yeah. have a... I have a Rust... Oh, it's because it's not a Rust debugger, okay. What's the... What is it? Run... Run without debugging is Control F5, okay. Yeah. I'll just use terminal for now. I can figure that out more later. But yeah, yeah, that's upset. Println can do many kinds of formatting, and default the curly brackets tell it to use formatting known as display out. Display output intended for direct end user consumption. Prims we've seen so far implement display by default because there's only one way you'd want to show a 1 or any other primitive type. Yeah, theoretically, but you can worry about that later, yeah. With structs, the way println should format is less clear, there's more display possibilities. Commas, curly brackets, all fields, etc. So... yeah, ooh. In format strings, you may be able to use question, okay? Yep. And that actually says that here, too. So... da-dum! And hash, hash question for pretty print. Alright, so... run this. Oh, it doesn't implement debug. Huh. Yep. Yep. Debug not implemented. Add derived debug. So that is, hash bracket derive friend debug. Okay. Now are you happy is the question. Yes! Woo! That's cool. I like macros like that. Alright. Yeah, macro annotations like that are cool. Now when we run, we won't get any more errors and we'll see the following output. Yay! Alright. Yep. Awesome. Not the prettiest output, but it shows the values of all the fields for this instance, which would help during debugging. When we have larger structs, useful to have output that's a bit easier to read, so throw a hash in there. Yay, multi-line, pretty printing. Alright, then there's also dbg correct one is I forgot to put in quotes. Yeah, that would be correct one is colon hash question mark. I accidentally hit colon hash question mark. And boop. Unclose delimiter where? What? Who? Oh, did I oh no, I accidentally deleted that. Thank you. Oh, I forgot to save. Whoops. Woo! Right. Oh, takes ownership, prints file and line number where that debug macro. Okay, I see. Yeah. Got it. Neat. Prints standard error console is occurred to println. Alright. Turned out. Yep. Okay, chapter 12. Got it. Yeah. So instead of that, we can just, we don't even need that, we just need, oh, we can even, if we split this out, we could dbg 30 times scale, let scale equal 2, and rect 1. Now if I cargo run, alright, yay! Now it prints out like line numbers and such, yay, that's good. Yeah, alright, yeah. Neat stuff. Ah. Ah! Alright. And, yeah. Because debug returns ownership of the expression's value, with field will get the same value as if we didn't have the debug call there. Don't want debug to take ownership of rect1, so we use a reference to debug in the next call. Okay. Yep. Yep. Looks good to me. Right. Yeah. You can see the first bit of output came from source main RS line 10, where we're debugging 30 times scale, and this resulting value is 60. Yep. Debug formatting implemented for integers is to print only their value. Debug call line on line 14 outputs and direct 1 rectangle struct. Use the pretty debug formatting of the rectangle type. Debug macro can be really helpful when you're trying to figure out what your code's doing, okay? I like that, you know, I like the implications of this. Namely, that, they don't, like, this is, your debugging here is using just a print statement that also has line number count. You don't, like, the debugger's not as crucial here. I like that. Fuck debuggers. Inaccessible as hell. Okay, so... yeah. Okay, anything else? Alright. Back over to this. Next up, so yeah. In addition to debug trait, Rust has provided a number of traits for us to use with derive, okay? Listed in Appendix C. Cover how to implement these traits with custom behavior and as well as how to create your own traits in Chapter 10. Got it? I want to take... alright, so derivable traits. Alright, debug for programmer output, yep. Partial like an ek. Yep. You mind going into why you think debuggers are inaccessible? Where do I begin? I mean, most debuggers are primarily designed for CLI usage only. That's not accessible. Just straight out, if your debugger is CLI only, that's an accessibility failure. Like, on top of that, they're also like very, yeah. I've spent some time with GDB. That was not a good experience at all. Just like, if you make one keystroke mistake, you're just completely screwed and have gone deep into a function that you don't have any hope of ever getting out of at a reasonable rate with your stepping and everything. It's just... there are a lot of issues with... yeah, suppose I'm thinking specifically of debuggers built into IDEs like Visual Studios and VS Code, yeah. Built-in debuggers and visual debuggers are a bit better, but, like, they are still, like, they're really confusing and can end up misleading you a lot more if there's a lot going on behind, like, behind your view. Like, if macros or prints are more complicated than you think they are, they can just end up not really, like, there's such thing as too much information, and debuggers are very, very liable to give you too much information. Yeah, like, sometimes you just want to know the state of one thing, but in trying to figure out the state of that one thing, you'll come across 50 other things that are just not what you're there for, and don't help, and just only make things worse. That's not good. There should be, like, a way to, like, flag and trace a specific object. Yeah. Yeah. Alright, so partial ec allows you to compare instances of type to check for equality and enables use of equal, equal, and not equal. Partial ec implements ec. Deriving implements ec, yep. Two structs are equal only if all fields are equal, and instances are not equal if any fields are not equal, okay? When derived on enums, each variant is equal to itself and not equal to the others. Required with use of assert ec, yep. Ec has no methods. The person is to signal that for every value of the annotated type, the value is equal to itself. Ec trait can only be applied to types that also implement partial ec, though not all types that implement partial ec can implement ec. One example of this is floating point number types. The implementation of floating point numbers that two instances of nan value are not equal to each other. Interesting take, thanks for sharing. Yeah, like, just usability, like, just being able to do what you want is a really important part of accessibility, and getting confused and, like, just having too much excess information that gets in the way of doing what you want is really bad. That can lead to overwhelm, it can lead to more confusion, it can lead to making things worse. So, like, having, like, just a macro for, hey, print out exactly what the fuck this is right now, is a lot more useful than a full debugger in a lot of cases. Like, full debuggers are for, like, I feel, are for when something is deeply, deeply wrong with your program, and especially when it's something that is beyond your control. Like, if you have to, like, step through other people's processes, that's when you're using a debugger, usually. Yeah, Alright, yep. Ec is required for keys in a hash map KV, so a hash map can tell what the two keys are the same, yep. Okay. Okay. Partial OR and ORed for ordering comparisons, yep. Partial OR can be used less than, greater than, less equals, greater equals, okay. Implements partial comp, option ordering, none when values given don't produce an ordering, okay. Partial OR compares two instances by comparing the value in each field in the order which the fields appear in the struct def. When derived on enums, variants of the enum declared earlier in the enum def are considered less than the variants listed later, okay. Gen range method from rand crate, okay. Yep. Ordered trait allows you to know that for any two values of the annotated type, a valid ordering will exist. Ordered trait implements comp, which returns an ordering rather than an option because valid ordering will always be possible. It only applied the ordered trait to types that also implement partial ORed and ec requires partial ec. When derived on structs and enums, comp behaves the same way as derived implementation for partial comp. ORed is required when storing values in a B-tree set, data structure that stores value based on sort order. Alright, clone and copy. Yeah! Clone trait allows you to explicitly create a deep copy of a value. Duplication process might involve running arbitrary code and copying heap data, okay? Driving clone implements clone return implemented for the whole type calls clone on each of the parts. Means all the fields or values must also implement clone. Clone is required when calling to vec on a slice, yep. Doesn't own the type instances it contains, but the vector returned from tvec will need to own its instances, so tvec calls clone on each item. Thus, the type stored on the slice must implement clone. Copy is just by copying bits stored on stack. Okay, so that's stack-only data. Doesn't define any methods to prevent programmers from overloading those methods and violating the assumption that no arbitrary code is being run. Now, all programmers can assume that copying a value will be very fast. You can drive copy on any type whose parts all implement copy. The type that implements copy must also implement clone because the type that implements copy has a trivial implementation of clone that just does the same task as copy. Rarely required, types that implement copy have optimizations available, meaning you don't have to call clone, which makes the code more concise. Everything possible with copy you can also accomplish with clone, but the code might be slower or have to use clone in places. Right, then hash lets you take an instance of type of arbitrary size and map that instance to a value of fixed size using a hash function. Implements hash, so derived impl combines the result of calling hash on each of the parts, yep. Hash map, alright, yeah, so that's important for hash mapping. And default for default values. Default, commonly used in combination with struct update syntax, yep. You can customize a few fields of a struct and then set and use the default value for the rest of the fields by using .default. Ooh, that's actually pretty cool. I will keep that in mind. Alright, so .default for if you just want to like empty everything else during like a struct init, okay? Required when used unwrapper default, okay. If options none, method unwrapper default will return the result to default for type T. Got it. Arrays function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior more closely to a rectangle struct because it won't work with any other type. Let's look at how we can continue to refactor this code by turning the area function into an area method. Woo! Oh, I can't wait. Method syntax. Declared with fn keyword and their name, have parameters and return value, and they contain some code that is run when they're called from somewhere else. However, methods are different from functions in that they're defined within the context of a struct or an enum or trait object, which we cover in chapter 6 and 17 respectively, and their first parameter is always self, which represents the instance of the struct the method's being called on. Probably and self, yeah, and self it looks. So, alright, so we're gonna, let's just throw this up here over by rectangle. So, impl rectangle. Alright, then instead of rect and rectangle, we can and self, then self width times self height. There. And then, instead of calling that, we can do rect1 to area. Woo! Alright. Now, if we run this, it should do the same thing. Yeah. 1,000 square pixels, so it's 30 times scale equals 2, yep. Looks good. Find the function within the context of rectangle will start an impl block, okay. Everything within the simple block will be associated with the rectangle type. Alright, yeah. You know, the best thing about, like, learning Rust right now is this is really giving me, like, a great view into, like, how OO stuff works under the hood. Like, I think that's neat as hell. I really like that. So yeah. Yeah. You know, like, being able to, like, learn how this is, like, how this works. Like, to learn how OO stuff works and, like, associates, like, things like this just by, like, reading the book for Rust is honestly so fucking cool to me. That makes me just really fucking happy. Like, wow. Just words. Oh no, wrong tab. I misclicked link someone sent me. it doesn't look to be safe for work, but it is not topical, and, like, looking at, cute boys being dressed up as cute girls is delightful, but I don't want to distract myself too bad right now, so we'll check that out later. Okay, so, yeah. Yeah, like, just being able to, like, learn how, like, OO stuff works by learning Rust, just, like, looking under the hoods of, like, oh, wait, functions are just a, like, or, like, methods are just a function associated with, like, a type. And, like, you just pass, like, a reference to that, to, like, an instance of a type in, and that's what, like, this keyword is, or, like, self in Python or whatever. Like, yeah. I think that is a really, really good way to do things. Self is a keyword, yeah? We use and self instead of rectangle and rectangle, yep. And self is usually short for self and self. Alright. Input block type self is an alias for the type. Alright, so that's just a natural alias. God, this compiler is cool. Like, this is so interesting. Like, holy shit. Like, this is actually, like, this is so cool because it's, like, teaching me how the language works at, like, a much more technical level. Like, I'm seeing all these, like, things that the compiler's doing instead of just assuming it's magic. I like that. I really, really like that. We should have more... There should be more languages with, like, documentation like this. What the fuck? Like, oh, that's so cool. That's so cool. Just wow. Just wow. I am, like, genuinely blown away by this. Yeah. Like, there is a lot getting masked here. Like, just, if I go into, like, target, debug, deps, and, like, just, there is, like, where did that, like, if we look at, like, one of these rusthello.s's, like, there is a lot being masked. Like, there's a lot being covered up here. But, like, it's so interesting, like, how much of this, like, is just, like, it's not going into, like, the hard number details of how it works, but it's still, like, just, it's so good. It's so good! It's so good! Like, I'm just... yeah, like, I'm having trouble figuring out words for, like, how cool all of this is. Ultimately, like, there's so much just neat. Like, it's really telling you, like, if not on, like, a byte-for-byte level, it is, like, telling you, like, how, like, the compiler thinks and, like, how things get associated. I like that. I really, really like that. That is just so good. Like, I want to make stuff like that. I want to, like, make things that I can document to this, like, level of detail of, like, how, like, comprehensive this is. Like, it makes you understand how the language works, not just what to do. That's, I like that. God. I'm just talking in circles here. Let's keep going, yeah. Start an input block, yep. Everything within will be associated with rectangle type, yep. You know, like, even saying there, like, just, like, having, like, the struct def and, like, the impls separated, it shows, hey, these aren't like yeah, now you're seeing why I love C, yeah. You know, like, this is like making me appreciate lower level stuff better. Like, I would really like to learn C after I learn Rust. I'm learning Rust just because having to, like, directly tamper with memory is terrifying to me. So, like, I'm starting with this, then I'm gonna be ready to dip my toes in with C. Yeah, yeah, like, I find, like, programming language design really interesting. Like, I have studied, like, a lot, or, like, I've learned a lot of languages. Like, I know Java, I know, like, some Kotlin, which means I also know some Swift. I've done a lot with Python. I'm learning Rust now. I've got experience with JS, because of course you gotta, and, like, just every language, hell, I had a job writing PHP once. Like, every language I like, even if I hate it, like, fuck JavaScript. Absolutely fuck JavaScript. But, like, every language I've, like, worked with, there's always been something really interesting to learn from how it was designed. Like, what thought processes went into it. Like, Python was designed all around being, like, easy to pick up, and being, like, as simple and, like, dev-friendly as possible at the cost of performance. Rust is really going in on being, like, friendly, like, it's got a lot on, yeah, PHP design is head empty, make things work. No, PHP was a mistake. Like, PHP was not meant, it was not meant to be this. That's the thing. That's what I meant, yeah. Yeah, like, it was, like, hell, it didn't even have a formal spec until 2014! Like, yeah, like, early history, yeah. PHP development began in '94 when Rasmus Lerdorf, wrote several common gateway interface programs in C, which he used to maintain his personal homepage. He extended them to work with web forms and to communicate with databases, and called this implementation, personal homepage forms interpreter. And it was just like a hypertext preprocessor. And then, early PHP was not intended to be a new programming language. It grew completely organically, yeah. Yeah, exactly, like, just, that's really interesting. Like, that, there's a lot of things you can learn from that, and, just, it's really obvious how ad hoc it was. JavaScript was written by a Nazi in 10 days to make buttons animate in Firefox. Fuck Brendan Eich. Ugh. Yeah, like, oh, like, I have so much, like, I have respect for PHP because it was not meant to be a programming language. I have no respect for JavaScript. Someone made that and meant it to be used as a programming language to write programs in. It was still Netscape at the time began meeting, yeah. Oh, it was Netscape, yeah, still. Like, fuck Brendan Eich, fuck JavaScript. If there's one thing JavaScript has done that is good, it is be so fucking terrible that nobody wants to write in it, and we got WASM. Like, JavaScript was, like, there is but, like, despite all that, there is something important to keep in mind with JavaScript. JavaScript was designed to just work. It was designed to just work. It would, yeah, it, like, is super forgiving. It will hardly ever crash. And that's because it wasn't meant to. It was meant to be as fuzzy as HTML and CSS are, where your browser will not crash if it goes wrong. Granted, there are 100 different ways you could do this better, of like just having errors that like halt execution in sandbox, but sure. But yeah, no, I don't like, yeah, there's issues I have with, like, yeah. I don't like JavaScript. There's things that, like, yeah, like, I don't like JavaScript. I think there were better ways to write a fail-safe language, and I'm so glad that WASM exists, so we never need to use JavaScript again. If it wasn't 40 minutes, I would definitely, like, show off the birth and death of JavaScript on stream. It's such an interesting talk. It's such an interesting talk. But yeah, like, every programming language has something you can learn from it. Like, Java, you know, like, okay, I've got lots of issues with Java in the same vein, yeah. Oh, don't get me, oh yeah, Java. Java is a mature language. It's a competent language. It works. The only time I've written Java is in a Minecraft context, and there's a very good reason for that. Yeah, like, there is some just magic with, I see that smile. Yeah, like, have y'all seen what ZGC on the JVM has been doing? Slightly crazed look in the eye. Like, have y'all seen what ZGC has been doing? Yeah, there's not as much in Java 17, but y'all need to see what's new in JDK 16. 1 millisecond max pause time. Yeah, like, I don't doubt the tech behind Java. Yeah, like, I have so much respect for the JVM. I just have disagreements with language design, yeah. I should get some cough drops. I'll go get those in a second, but yeah, like, the JVM, really good, really cool. Java language needs improvement. My voice is going a bit hoarse. I will be right fucking back with some cough drops. Give me a minute. I could have sworn I deleted, like, the music player on this scene. Whoops. I'm back. I have a cough drop. Turns out that possibly having COVID and having to stick a cotton swab up your nose to test for that, and also Adderall, makes you really dehydrated, and that makes you cough a lot, yeah. Yeah. Honestly, I feel pretty similar about Rust, but most of my disagreements come down to the syntax and intense priority placed on memory ownership and safety, which I feel is stifling personally. Yeah, that's fair, yeah. There's, like, a bit of syntax weirdness, like, you'll notice over, like, on my code here, I am, like, using, like, the return statements and such instead of, like, instead of just having an expression, just because I find that a lot better for me. It just works a bit better with my mind. Okay, so, yeah. The JVM is one of the most powerful and like, genuinely one of the most ingeniously designed pieces of software ever. It is so good. Yeah. Yeah, like, there is, like, just a bit of design weirdness with Java that you have to get used to. You're like, that is something I've noticed with me. I'm very good at, like, getting used to, like, language weirdnesses, as long as they're not, like, really bad. Like, I can get used to a weird syntax. Hell, I got used to Python and people hate that. Like, to make it clear, I'm the gal that loves list comprehensions. Like, I've got some ridiculous list comps in GBS Toolkit. And I love each and every one of them. Love Python list comprehensions are amazing, yeah. Like, there's a list of programming, there are a few programming languages with, like, list comps. Yeah. Do I have... Alright, no, that's just background tones in this. Okay, yeah. Like, comparison of programming languages, the list comprehension, yeah, like, there are a lot of languages with, like, similar things, so, like, that's just, yeah. Alright, yeah, so that's .NET. Ooh. That's more like query syntax, but, yeah. Yeah, this is more query syntax than, like, a comp. Like the Python-style comp, but yeah. Yeah. Yeah, there's, like, a lot of languages, like, Clojure's got them. Comps are a very, like, functional programming thing. Ooh, CoffeeScript has them, but that require coffee. Link is the C# way of doing comprehensions, yeah. Yeah. Yeah, I've been thinking I might, like, learn some, like, C# or .NET stuff at some point. Yeah, like, yeah, Dart, yeah. Yeah, this is, like, yeah. Yeah, that's just, like, function mapping, yeah. Java has, like, Stream API, which is not quite a comprehension, but... yeah, like... useful if you ever find yourself in a Unity house, yeah. Unity, Unreal, like, Godot's got mono support. Yeah, Mithril, yeah. Nim. Yeah, Nim's got, like, kind of, like, its collect thing, but... yeah. OCaml, yeah. Perl. Yeah, Python, of course, like, the king of them. Rust does not have built-in list comprehensions, but they can be replaced with iterators, yeah. It's just got, like, your typical filter map stuff, which makes me sad. How much can you do with, like, Rust macros? You know, like, Oh, this is later on in the book. Okay, yeah. Declarative macros. Okay, so derivative, attribute-like macros, and function-like macros. Okay. So yeah, like... Yeah, there might be some way to do it, but yeah. I like list comps. They're cool. But yeah, so impl block. Yeah, back on track, like, instead of talking about languages, but yeah. Like, yeah, impl block, they're, like, associated. Yep. Then move the area function within the impl curly brackets. Yep. Change to self. Self is an alias for the type the impl block is for. Methods must have a parameter named self of type self for their first param. Like, I think, like, this is, like, the big reason I bounced off C, like, when I first tried to learn it is, like, it's not really good at, like, teaching you what stuff is doing, just, or, like, the classes I took weren't good at teaching what stuff is doing, just how. Like, I find I really only get interested in, like, learning a language if I'm learning the how. Like, same with a lot of stuff, like, if I'm just learning what, that's just memorization and it sucks. If I'm learning the how, that is when it gets really interesting to me. Methods can take ownership of self, borrow self immutably, or borrow self mutably, yep. Self here for the same reason we used in rect, yep. Don't want to take ownership and we just want to read the data in the struct, not write to it. We wanted to change the instance that we've called the method on as part of what the method does. We'd use enmute self as the first parameter, yep. And the method that takes ownership of the instance by just using self as the first parameter as well. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. Alright, yeah. Okay. Main benefit of using methods instead of functions is for organization. Yay! Yep. Just put it all in one impl block. Now it can choose to give a method the same name as one of the structs field. Yep. We note that we can choose same name as one of the structs fields just because paren, so yeah. Yeah, that's neat. Choosing to make behavior the with method, yep, because a variable name and a function name are different. That is interesting. Does Rust have, does Rust have first class functions? Oh. Huh. But are Rust methods first class? That's an interesting question. Right, so there are closures, which is interesting. Of Rust, yeah, Rust first class methods. Yeah, not sure if we'll learn about that. I can just experiment with it later, but yeah, like, the fact that you can have, parameters and functions, or fields and methods named the same, that does, yeah. Right, yep. Often but not always, methods with the same name as the field will be defined to only return the value in the field and do nothing else. Methods like this are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private, but the method public. Oh, thank you for the hydrate, non! Now, Actually, no, I can test this quick. So, dbg and rect1 dot area. Is that legal? No. I don't wanna. Yeah, method not a field. Okay, so methods are not first class. Where? Makes sense. I'm sad. I like first class things. They can be fun to mess around with, but it's very reasonable, like, it's very reasonable that functions are not first class. Actually, println, or no, bg, rectangle area. Oh! Is that legal? Is that legal? Oh wait, I forgot to save. Is this legal? No! Boo! Oh wait, because it doesn't implement debug. But, functions generally aren't first class in low-level languages, yeah. Let func equals, yeah, rectangle area println func and rect1 is that legal? Is that legal? First class method. If this is legal, this will be very funny. Woo! Okay! They are! Oh, that's tasty. That's tasty. This is evil and tasty. I love it. Okay. Oh. Oh, that's delicious. I love this. Ah, so good. Not what I wanted to do. Oh wait, yeah. You mean function pointers, yeah. Basic, yeah, it's equivalent to function pointer, yeah. Yeah, it sugars down to a function pointer, but yeah. You're like... Ah. Yeah, that's cool. That makes me happy. Yeah, you can pass around function pointers anywhere. Yep. Yes, that, yeah. Mm-hmm. Yeah, just like... Yeah, like... The thing I like about Rust is... Pointers I have found hard to wrap my head around, and so, like... Thinking of it as a first-class method, just makes a lot more sense to my, just to, like, my mind at the moment. See, just because, like, primary experience is Java and Python. I only know high-level shit. Yeah. Pointers are just references you can rebind, yeah. Like, I know what a pointer is, I just can't manipulate them the proper way in my mind a lot of the time. Right, so... Methods with the same name as field will be defined only return. Like this are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Useful because you can make the field private but the method public and thus enable read-only access. We'll be discussing public and private and how to design a designated field or method as public or private in Chapter 7. Okay. Lots of folks have trouble with them, yeah. Yeah, just like... thinking of like function pointers as like first class functions makes a lot of sense to me. And like just I know like I know like fundamentals of ASM mostly just due to watching Ben Eater stuff and like 6502 ASM, and like just that makes a lot of sense of like why you can pass a function pointer around, because like what it effectively comes down to is I can just put it here. So like what a function pointer effectively comes down to is like then function pointer no. Then like so like you've got a function pointer there, then like you've got a push a t x a, then yeah, or you've got like your assembly, then RTS, then you can just like then you can have like jump, yeah, then you could also have like your jump function, or yeah, JSR function pointer pointer. But because function pointer is just like and like yeah, because your function pointer is just like a location in assembly, you could like yeah, you could like just set x to, yeah. Function is effectively just a memory location in the program code. Calling a function pushes arguments and the return address on the stack. Yep. Yeah, exactly, yeah. Yeah, then like yeah, I'm not sure what, like, I don't remember the 6502 instruction to like just put like a raw value, but yeah, like you could just put like the point there into a function pointer, then just do jumps on that and such. So yeah, that's basically a function pointer. Yeah, that makes a lot of sense. Just like calling it in my brain like a first class function just makes a lot of sense to me. Yeah, and yeah, in C and C++, yeah, where's the arrow operator? In C and C++, two different operators used for calling methods. Use dot if you're calling a method on the object directly, and arrow if you're calling the method on a pointer to the object and need to deref first. Rust doesn't have an equivalent to the arrow. Rust just references and dereferences automatically, which I think is cool. I like when the compiler does stuff for you. Calling methods is one of the few places in Rust that does auto-ref and deref. When you call a method with object.something, Rust automatically adds in and mute or star so object matches the signature of the method. In other words, the following are the same, okay? Yeah. First one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver, the type of self. Given the receiver and name of a method, Rust can figure out definitively whether the method is reading, mutating, or consuming. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice, yeah. I think that's, yeah, like, I think that's cool. Yeah, methods with more parameters. Alright, so... Yep, so... Methods by implementing a second method on the rectangle struct. When make an instance of rectangle to take another instance of rectangle and return true if the second rectangle can fit completely within self, otherwise it should return false. Yeah, then can hold and self, and... or rect other and rectangle. Yep. so then we can, like, I'll just turn this back to 30. Yeah, let rect2 equal rectangle. Oh, yeah. I'll just, yeah, I think I'm just gonna put them, like, single line like they're a constructor for now. Yeah. Yeah, so width 30, height 50, or no, 1040, yeah. And 40. Let rect, yep, then let rect 3 equal rectangle width 60, height 5. This also does another thing, yeah. Hello, Catton! Great to see ya! Alright, so yeah. Now, println can rect1 hold rect2. Rect1 can hold and rect2. Oh, I forgot to, yeah. Alright then. Print, actually, is it Control D? Is there like a... I forget, is there like a hotkey to, no, it doesn't look like there is. I remember, rect2 hold rect1 hold rect3. Rect1 can hold and rect3. Yeah. Now we just need to return self area greater equal other area. That should be right, yeah. Oh, semicolon? Now you're good, okay, yeah, so that should do it, theoretically. Right, yeah. I looked, yep, alright, yay. Though, to be fair, that's not, like, the best measure, yeah. Yeah. So, yeah, as the expected output would look like this, yeah. So the inside input yeah, I think I've generally got it, like I might just not want to use, I might just not want to use, like, the area functions, because that might not be, yeah. Yeah, it's recommending self width greater than other width and self height greater other height. Yep. Yeah, now that should be better, so yeah. I should, can I? Is there a way to, like, clear, nope. There. Just clearing out the terminal a bit, but yeah. You make a height 1 length 10 rectangle, it can't hold a height 2 length 5, yep. Alright, yeah. So run in main, yep. Multiple parameters add after and self. They work just like parameters and functions. Yay! All functions defined with an impl block are associated functions. Because they're associated with the type named after impl, we can define associated functions that don't have self as their first parameter and are thus not methods, as they don't need an instance of the type to work with. We've already used one function like this, the string from, that's defined on string. Yeah. That means we can then square size u32 to rectangle, return rectangle, width, size, height, size. Yay! They're not called static methods in Rust, I guess. Nope. That's like what they are equivalent to that, but yeah. Static method, yeah, static is a different concept in Rust than it is in Java, so they're called associated functions. Technically, all of these are associated functions, but some of them are specifically methods because they use self. And to call, you use double colon syntax with the struct name, so that would be like, yeah. Yep. Yeah. So yeah, then you could like, let q equals rectangle square 30. So, yep, like that. Right. Function is namespaced by namespaced by the struct syntax is used for both associated functions and namespaces created by modules. We'll discuss modules later, yeah. Now, here's an interesting thing. Each struct is allowed to have multiple impl blocks. For example, listing 515 is equivalent to the code, shown listing 516, which has each method in its own impl block. That's a thing. No reason to separate these methods into multiple impl blocks, but it is valid syntax. We'll see a case in which multiple impl blocks are useful later on in the book. Yeah, like, basically the thing with multiple impl blocks is that now somebody can implement their trait on your function. For the Java side, like Minecraft modding side, that's like mixing an interface into your class, which is helpful. Yeah. Alright. In impl blocks, you can define functions that are associated with your types. Methods are kind of associative functions that let you specify the behavior that instances of your structs have. Enums and pattern matching. On to chapter 6. This should be fun. I'm gonna clean out my main and all this stuff up here. Just because we're starting a new area, so yeah. Alright. In this chapter, we'll look at enumerations, referred to as enums. Enums allow you to define a type by enumerating its possible variants. First, we'll define and use an enum to show how an enum can encode meaning along with data. Next, we'll explore a particularly useful enum called option, which expresses the value can be either something or nothing. Then we'll look at how pattern matching in the match expression makes it easy to run different code for different values of an enum. Finally, we'll cover how the if-let construct is another convenient and concise idiom available to you to handle enums in your code. Enums are a feature in many languages, but their capabilities differ in each language. Rust's enums are most similar to algebraic data types in functional languages such as F#, OCaml, and Haskell. I've never used any of those languages, so let's go! Alright. Let's look at a situation we might want to express in code and see why enums are useful and more appropriate than structs. Say we need to work with IP addresses. Currently, two major standards are used for IP addresses, IPv4 and IPv6. These are the only possibilities for an IP address that our program will come across. We can enumerate all possible variants, which is where an enumeration gets its name. So that would be enum IP adder kind v4 and v6, like that. And express this concept in code by defining an IP address kind enumeration. Yeah, like this. Alright, now you can let 4 equals IP adder kind v4, let 6 equals IP adder kind v6. What the fuck? What the fuck happened to IPv5? Was that ever... Oh, it was just never adopted. Lemma. What'd it do? Internet Stream Protocol, okay. STIPv5 was developed as a means of streaming video and voice data by Apple Next and Sun Microsystems. Oh boy! It was experimental. Transferring data packets on specific frequencies while maintaining communication. Alright, 32-bit addressing. Oh, yep. Yeah, that's why it was turned up, so yeah. It's like, this is about, like, the actual internet protocol, not just the addressing, but yeah, it just used, like, 4 bytes again. Like, again, like, yep. By 2011, yep. Yeah, 2011 IPv4 was all gone. It was just abandoned, and we moved on to IPv6, which has 128-bit addresses. Which should hopefully be enough. So yeah, hopefully that'll be enough. I think, yeah, like, we'll see, but yeah. Remembers XKCD about nanomachine stopping at half a worth? Yep. Yeah. Now I've got enum values. Now we can also make a fun root. IP kind, IP adder kind. Then we can, root IP adder kind v4 or root IP adder kind v6. Yeah, using enums has even more advantages. Thinking more about our IP address type, at the moment we don't have a way to store the actual IP address data. We only know what kind it is. Yeah, given that you just learned about structs in Chapter 5, you might tackle this problem as shown in 6.1, so you've got a kind and a string address. Yeah. Yep, so you could do something like this. You've defined a struct IP address that has 2 fields, a kind field, that's of type IP address kind, and an address field of type string. You have 2 instances of the struct. First, home is value v4 as its kind with associated address data of 127.0.0.1. Then second instance, loopback has the other variant of IP address kind as kind value v6 and address : 1. Yep. Yep, associated with it. We've used a struct to bundle the kind and address values together, so now the variant is associated with the value. But we can represent the same concept in a more concise way by just using an enum. Yep. Yep. Yeah, rather than an enum inside a struct, by putting data directly into each enum variant. This new definition of the IP address enum says that both v4 and v6 variants will have associated string values. So now you just need to do string from 127.0.0.1 and string from 1. So yeah. We attach data to each variant of the enum directly, so there's no need for an extra struct. Here it's also easier to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of the enum. That's cool. Yep, that is IP address v4 is a function that call that takes a string arg and returns an instance of the IP address type. Automatically get this constructor function defined as a result of defining the enum. This is cool. Yeah. There's another advantage to using an enum rather than a struct. Each variant can have different types and amounts of associated data. Version 4 type IP addresses will always have 4 numeric components that will have values between 0 and 255, so that just could be U8, 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 U8. So that then becomes 127001. And then you can use the string for v6 because those are weird. I think like the IPv6 shortening syntax is important, but yeah. Maybe I should get an IPv6 block sometime. That'd be fun. Yeah. If we wanted to store IPv4 addresses as 4 U8 values, but express v6 addresses as one string, wouldn't be able to with a struct, so now we've got this. And because it's an enum and there are a finite possible number of things it can ever be, you can write code to handle each specific type. Yeah? Yeah, like, you would have shown you several ways to define data structures. Yep. Turns out wanting to store IP addresses in code which kind are so common, the standard library has a definition we can use. Let's see how they do it. Yep, so IP address, then before it's just an IPv4 address, which provides a from stir. Alright. Fields emitted, yeah. Oh, they are just straight 32-bit. Alright, they are just U32, okay. There's source if you want to see the whole file, yep. Yep, but that is, like, it's just using C types there. Yeah. Not important. So yeah, you've got fromster and IPv4 addresses and such. But yeah. Yep, and then IPv6s are probably just, yep, 128-bit int, so that's just another, like, C-type. Yeah, yeah, there was a really interesting, yep, yeah, netc, okay. There was a really interesting thing I saw a little while back that I might be able to find again. Of, like, just, moving Rust's standard lib away from using libc. That would be, like, that might be interesting. Might not be super useful because libc is very mature, but it would be neat. Yeah. Just, like, at a conceptual level. I personally don't really like things that are fully bootstrapped because if you're trying to bring it up on a new ISA, have fucking fun! This code illustrates that you can put any kind of data inside an enum variant, strings, numeric types, or structs. You can even include another enum. Also, standard lib types are often not much more complicated than what you might come up with. Even though the standard library contains a definition for IP address, we can still create and use our own def without conflict because we haven't brought the standard libs into our scope. Yay, scopes! Alright, here's another. Yeah, here's another, so we can pull this out. Enum message. Quit, move, X, I32, Y, I30, I32, I2, right, string, change color, I32. Yeah, you should just be U8 if you're changing color. But yeah. Yeah, like just... This is a cool one. You're defining the struct remove right there. In named fields, yep. Single string, then... Yep. Yeah. Defining an enum with variants such as the ones in listing 6.2 is similar to defining different kinds of struct defs, except the enum doesn't use the struct keyword, and all the variants are grouped together under the message type. Following structs could hold the same data that the preceding enums hold. Yep. The quit method's a unit struct. A move message is just x and y named. Yep. And two tuple structs. But if we use the different structs, which each have their own type, we couldn't as easily define a function to take any of these kinds of messages as we could with the message enum defined in listing 6.2. Yep. Alright, here's a really sensitive tonight. One more similarity between enums and structs, just as we're able to define methods on structs using impl, also able to define methods on enums. So, now, impl message, and call, and self, method body here, yeah. Very nice. Yeah, enums and rest are essentially discriminated unions. Yep. You know, enums and... Yeah, like, from what I've seen of enums and pattern matching in Rust, they are, like, one of the best things. Big fan of discriminated unions, yeah. Like, enums and, like, pattern matching in Rust are one of the best things about Rust, I think. Just from what I've seen. So yeah, then you could let m equals message, write... string from hello, capital, then call, yep. Yeah, something like that. Body of the method would use self to get the value that we called the method on. In this example, we've created a variable m that has the value message write, string from hello, yep. And that's what self would be in the body of the call method when mcall runs. So let's take another let's look at another enum in the standard library. Option! Because who fucking needs nullability? Yeah. In the previous section, we looked at how the IP address enum let us use Rust type system to encode more information than just the data into our program. This section explores a case study of option, which is another enum defined by the standard lib. The option type is used in many places because it encodes the very common scenario in which a value could be something or it could be nothing. Expressing this concept in terms of the type system means that the compiler can check whether you've handled all the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages, like, you know, null pointer exceptions. Programming language design is often thought of in terms of which features you include, but the features you exclude are important too. Rust doesn't have null. Null is a value that means there's no value there. And null breaks type safety. Yeah. In his 2009 presentation, Null references the $1 billion mistake. Tony Hoare, the inventor of Null, has this to say. At the time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of the references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage over the last 40 years. The problem with null values is that if you try to use a null value as a not null value, you'll get an error. Because this null or not null value property is pervasive, it's extremely common to make. concept that null is trying to express is still a useful one. A null is a value that is currently invalid or absent. Problem isn't really with the concept, but with the particular implementation. As such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option, and it's defined by the standard library as none or some type T. Option enum is so useful it's even included in the prelude. Don't need to bring it into scope explicitly. In addition, so its variants, you can use some and none directly without the option prefix. Option T enum is still regular enum, and some T and none are still variants of type option T. T syntax is a feature of Rust we haven't talked about yet. It's a generic type parameter covered in Chapter 10. Jesus Christ, Chapter 10 does a lot. Oh, it's generic, yeah, like generic types, traits, and lifetimes. That's really big stuff, so fun. All you need to know is that T means the sum variant of the option enum can hold one piece of data of any type, and that each concrete type that gets used in place of T makes the overall option T type a different type. Here's some examples. So, like, you've got option I32. You've got, yeah, like, here's an option for an I32. Yeah, here's option and stir. But yeah, Rust can infer these types because we specified a value. But for absent number, we need to annotate the overall option type because none does not bring any type with it. Alright. Compiler can't infer the type from the corresponding sum variant will hold by looking only at a none value. So yeah. When we have a sum value, we know that a value is present and the value is held within the sum. When we have a none value, in some sense it means the same thing as null. We don't have a valid value, but now we know that it does have a chance of not being there, and we have to account for that in code. Yeah, like, you can't add an I8 and an option I8. You gotta handle that first. Hooray, mandated safety. Yep. In other words, you have to convert an option T to a T before you can perform T operations with it. Generally, this helps catch one of the most common issues with null, assuming that something isn't null when it actually is. Not having to worry about incorrectly assuming a not null value helps you be more confident in your code. In order to have a null value that can possibly be null, you must explicitly opt in by making the type of that value option T. Then when you use that value, you're required to explicitly handle the case when it's null. Everywhere that a value has a type that is an option, you can safely assume the value is non-null. Deliberate design decision, yep. How do you get the T value out of a sum? Option T's, enum has a large number of methods that are useful in a variety of situations. You can check them in docs. So, like, you got isSum, which basically just means exists. Is_none, contains. Oh, nightly only experimental API, Returns true if the option is a sum value containing the given value, Alright. And that just, like, passes in like a direct type, okay. Yep. Then, as ref, converts from end option T into option and T, that feels like... Is that magic? No. Okay, so... Alright, ref keyword, got it. Then as... Yeah, so that's as ref, yep. Then this, like this, yep. So converts option string into an option usize, preserving the original. Yeah, just using a map op, okay. Yep, as mute, lets you, yeah. Mute option T to option and mute T. As pin ref. What the fuck are you? Oh. Pointers, okay. Don't care. I'm not gonna do pointer stuff yet. Then expect. This is important. Returns that contains some value consuming the self value. And will panic if it's none. That's helpful. Alright, unwrap returns that contains some value consuming the self. Because this function may panic, it's generally discouraged. Instead, use pattern matching. And if, yep, that panics if self equals none. Then there's unwrap or with a default. Yep, and unwrap or else. What's... Oh, returns that contains some value or computes it from a closure. Okay, got it. Unwrap unchecked. Oh no. Oh no. Calling this on... Yeah, that's an unsafe function right there. Oh boy. Yeah, that's unsafe. And ooh, you've got maps. So max option T to option U. Yep. Yep, makes sense. Map or else. Okay, or yeah, lots of cool things. But yeah. Match expression, alright? That is a control flow construct that does just this when used with enums. It'll run different code depending on which variant of the enum it has, and that code can use the data inside the matching value. Alright, it's match time! Yeah, you should see and then. Oh boy, iter. Alright, iter, mu, and... Alright, so... Returns none if options not otherwise, returns up to B, okay. And then returns none if the option is none, otherwise calls F with the wrapped value and returns the result. Oh, that's just a flat map, okay. Okay, so yeah. Got it. Yeah. Makes sense. That's cool. Helpful. Alright, so Rust has an extremely powerful control flow operator called match that allows you to compare value against a series of patterns and then execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. Chapter 18 covers all the different kinds of patterns and what they do. Power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. Yep. So yeah. For example, we've got in coin, penny, nickel, dime, quarter. Then we've got fun, value in cents, coin, to byte, match coin, then coin penny, arrow 1, oh, that should be capital C, coin nickel to 5, coin dime to 10, coin quarter to 25. Then, you know what? Return and semicolon. Yeah. Yep. Alright, yeah, let's break down the match and the value in cents. First, we list the match. Yep, so first we have like a match keyword followed by an expression, which is just the straight value coin. There's a big difference with if the expression needs to return a Boolean value, but here can be any type. Type of coin in this example is the coin enum, yep. Then we got arms. there's two parts, a pattern and some code. First arm is, yep. So just so just a straight value is equivalent to equals. Then equals right angle bracket, so like 2-bar arrow. Alright, yeah, that's fine. Yeah, yeah, code in this case just the value 1. Each arm is separated from the next with a comma, yep. I don't like how the book has trailing commas. Like, I get they're safe, but... It just... Yeah. I just don't like how trailing commas look. I think that's just, like, the one... minor gripe I'm having with, like that and, like, the... Yeah. Yeah. Do you prefer initial commas? Or no, I mean, like, trailing commas, like... trailing commas mean, like, if you look in the book here, like, there's a comma even though there's no next term. Yeah, like, I don't personally like that. I would prefer to not have it there. Right, yeah. Alright, match arms. Yep. When match expression executes, compares the resulting value against the pattern of each arm in order. Match pattern matches the value of the code associated with that pattern is executed. If that pattern doesn't match the value, execution continues to the next arm, much as in code inserting machine. Yep. I need to quickly... alright. Oh no, I accidentally opened... Oh. Right. Yep. Alright, so curly brackets typically aren't used if the match arm code is short, as it is in 6.3, yep. If you want to run multiple lines of code in a match arm, you can use curly brackets. Yep. Yeah, like here you've got like a println, then return it. Right. Actually, no, not return match coin. Actually, is that? Println value in cents, coin penny. Nope. Is this legal? Cargo run. No. Variance is never. Alright, oh, that's warnings, okay. Alright, no, that's legal, okay, so. Alright, yeah, because match coin is just like outputting a value, okay. Is this, Alright. Println. Lucky penny. Is this still good? Yep. Alright. Like, just, this is like returning up to there. Okay, yeah. Okay, yeah. I think I get it, yeah. Yeah. Okay, yeah. There's a bit of, like, just weird, ness with, like, using return statements there, but yeah. That should be fine. Okay, so yeah. On to the next. Alright, patterns that bind to values. Another useful feature of match arms is that they can bind to the parts of the values that match the pattern. This is how we can extract values out of enum variants. Woo! Let's change one of our enum variants to hold data inside it. Yeah, Pacific Northwest state, and let's just put or NorCal yeah. Yeah. You know what? Fuck it. I'll call NorCal honorary Pacific Northwest. Oregon, Washington. Then I can ENW state. Then we've got a. Alright, then. Yep. Return 25. Then print ln state order from so colon question then close state. Yeah, you're good. Yeah. Oh, debug. Yeah, might be. Yeah, so you've still gotta derive debug. Oh yeah, what's NorCal? NorCal is North California. Yo Russ, hello Fever TV, great to see you. Yeah. Then println value in cents coin order NW state Washington. Yeah. I think there is one weird thing, like, you don't need a semicolon on the last statement, like on the last expression of a function. That's a bit weird. Yeah, just because like that turns it into like the return. That can just throw you off a bit and make you forget a semicolon you want to put. Like, that's much. Last expression is always returned. Yeah, like, I get that. It's just, it can just be a little weird. I don't, yeah, like, just, yeah. Yeah, like, the last expression is always returned. Like, I get it. It's just not my favorite little Rust quirk so far. Yep. Yeah, then we can just cargo run again. Yep. Yeah, something like that. Yeah, yeah. So yeah, that's cool. Alright, if we were to call value sense, yep. Got that, it's working. Now that we've got this idea done, let's do some matching with option, because that is one of the biggest things you're going to be doing here. Because there are a lot of times where things can just not work. So, alright, so let's say n plus 1 x option I32 2 option I32 match x none sum I not colon arrow sum I plus 1. Alright, wrong arrow. Let 5 equals sum. Oh, then, so let 5 equals sum 5. Let 6 equals plus 1 5. Let none equals plus 1 none. Yep. now we've got, like, that'll just result to none through that path. Some will go through one. Yep. Looks good. Yeah. Now let's consider the second call plus 1 in listing 6-5 where x is... Yeah, I think, like, the thing that weirds me out about, like, the trailing commas and things like this is that, like, there is the fact that there's no syntactical difference there, but there is syntactical difference to leaving out the semicolon at the end. I just don't think that's great. Yeah. Like, just, it's something I can deal with. It just, like, is a minor, Matches are exhaustive. You cannot just have one of them. That's a failure. It'll shout at you. Gotta be exhaustive. Yeah, then you've got... Yeah, but if you don't want to have that, then you can just... Yeah. Blank to none. Yeah, then you can just use an underscore placeholder. Yeah, underscore, or like if you're matching off a number, you can use other or whatever. Yeah, that's from implementing a game where if you get a value of 3 on a dice roll, your player doesn't move but instead gets a new fancy hat. Roll 7, your player loses a hat. All other values, player moves that number spaces. So yeah. Yep, you can just bind it to a variable. If you bind it to underscore, that just means you're never gonna use it. Alright. The example also meets the exhaustiveness because we're explicitly ignoring all other values. Yep. Change the rules of the game one more time so that nothing else happens on your turn. Yep. We can express that you can just use the unit value. Alright. I think there is, like, also a really good thing in, like, having, like, functions with no concrete return, not returning none, but returning unit value. I think that's a good thing. Yeah. Alright. More about patterns and matching that we'll cover in Chapter 18. For now, we're going to move on to if-let, which can be useful in situations where match is a bit wordy. Okay. Let's take a look at that. So, let config max equals sum 3u8. Right, okay, you're comparing it to Python none, yeah. Python none, Java, null, or whatever. Yeah, which is, like, basically what Rust has option none for, but yeah. Right. Alright, so then match config max sum max to println the maximum is configured to be and and cargo run. Wow. Oh wait, I forgot to put max. I am glad that it is a compiler when you aren't formatting properly. That's cool. Maximum is yep. Alright, so 3u. Alright, yeah, I like that as like a type. Yeah, I think that's a pretty alright way to like to inline type like a number. Yeah, I think that's alright. Alright, yeah. Then, alright, so instead we could write this shorter using if-let. Following code behaves the same as the match, so if-let sum max was config max println the maximum is configured to be max. Alright, yeah, so if let, okay, so sum max, right. Okay, so if let takes a pattern and an expression separated by an equal sign, okay. Alright, yeah, so it basically just takes that pattern, and if it matches that, yeah. Yep, okay. The pattern is sum max, and the max binds the value to sum. We can then use max in the body of the if let block in the same way as we used max in the corresponding match arm. Yep. Code an if let block isn't run if the value doesn't match the pattern. Okay. Is that equivalent? Is that like equivalent to like the walrus operator? Yeah, you know, walrus operator just, yeah, like, I think it's just some weird thing, so yeah, sign statements, right? Yeah, yeah, like, let me just give, yeah, walrus operator is an assignment that's an expression returns the assigned value, yeah. Right, I'm trying to, the syntax is, the syntax is a bit weird. I'm trying to wrap my head around, like, what this is actually saying. So, like, if let sum max is, like, would, like, a Java equivalent be, like, the new... Would, like... Would, like, an equivalent be, if I, like, just put this down here, like the if obj instance of, think of it more like a match statement but with only one arm. Yeah, I'm just like it just feels like the phrasing of it just feels weird. Like there is like the new instance of like direct assignment thing. Is that like, or yeah, I'm just trying to figure out, yeah. Oh, Nathaniel, well, by the way, yeah, it kind of feels like that. Yeah, okay, yeah. Like, if let just doesn't feel like a great... I don't think that if let was the, greatest thing to... Oh. Yeah. If it was like if match, yeah, it's a little like that. It's in the same vein. First bits of pattern matching in Java, yeah. Like if it was like if match sum max equals config max, that would, like, I think that, like, I think the issue is if expects an expression, but this is not like let sum max equals config max. That's not a, like, this is not a legal expression outside of if let. If you have an infallible pattern, you can use let to unpack it or whatever. Yeah, like, it just, this feels like weird syntax. I could get used to it, but I just don't understand the why. Yeah, you can do let, oh, you can do let a b equals 9, 8, can you? You can, huh? Yeah, I think just the main... Yeah. I think the main thing that is tripping me up here is there's not actually, like, any equality check here. Like, there's no, like... It just feels like this should... Like, this feels like it should, evaluate to a boolean if is being used. I don't know. If let and while let are sort of like a compound keyword, yeah, like just, I would not have an issue with it if it was, like, one keyword. Like, if let was, like, one keyword, I would have, yeah, let reverse A equals, yeah, let reverse A equals reverse A. Is that really? Then, yep, use and... Alright, if that's... Alright. Yeah, if that's, like, legal, then that's fine, yeah. If, like, yeah, you can't do, like, sum A equals sum 3, yeah. Okay. Yeah, yeah, alright, I think that makes a bit of sense, just, like, that's gonna take a little bit to get used to. You can't, yeah, the none variant isn't covered, yeah. Alright, so, yeah, I see, yeah. Alright, I think I get it, yeah. Yeah, like, I understand, like, on, like, I understand, like, on a use, like, I understand the what. I'm just getting a bit tripped on the how, because, like, just, I've been told that let is supposed to be a, yeah. I've just been told that let is supposed to be a statement. Yeah, it's useful, it looks, if let looks a little funny, yeah. Like, if there was, like, I wish there was just a different syntax for it. That's generally it. Oh well. Weird syntax choice, there's a lot of those in Rust, yeah. Like, I wish there wasn't. Like, I wish there was, like, just... Yeah, like, there's, like, a lot of the syntax in Rust makes a lot of sense, but, like, just... There's some that just feel a bit weird, and, like, isn't enough to, like, ruin the language for me. Like, I write Java and Python. Those have hella syntax. A lot of syntax in Rust I just wish were different, yeah. I think that's generally what it boils down to, is just, like, the syntax feels weird, like, yeah, I don't know, it's fine. Syntax if let takes a pattern and expression, yep, separated by an equal sign, works the same way as the match, where the expression is given to the match and the pattern is its first arm. Yeah. Like, I know, like, these are equivalent, just, like... Alright, so... Alright. Oh! I get what it is. Okay. No, alright, I found what is, like, the implicit part of it that makes it... Alright. Yeah, so, like, just... Alright, I figured... Alright, Alright, yeah. Yeah, basically, like, it's just got, like, an implicit, like, is this legal check on the end. That makes sense. Doesn't panic if it's not some, yeah. Yeah, just, like... I think I understand how that works now, yeah. So, yeah, I think, like, the implicit, like, legality check is kind of what I was missing. Yeah. That makes sense, no, yeah. It's like, it's kind of like, yeah. Yeah. That's, like, just inherently, true. This is, like, just, if let become, like, this just becomes inherently truthy, yeah. Okay. I wish that syntax was changed. I, like, if I cared enough, I would, like, if you can assign this to it and, yeah, exactly, yeah. Yeah, like, if let, basically, this is just wrapped in, like, an is legal, pretty much. Less typing, less indentation, less boilerplate. Yeah. Have you lose the exhaustive checking that match enforces? Tuning between match and iflet depends on what you're doing. Iflet's a syntax sugar, yeah. Like, luckily it's just a sugar, so I can just not use it if I don't want to, but yeah. We can't... Alright, there is an else with it, yeah. Yeah, like... Yeah, like, I might find a use case, like, while actually using it, but yeah. Now covered how to use enums to create custom types that can be one of a set of enumerated types, or values. We've shown how the standard libs option t-type helps you use type system prevent errors. When enum values have data inside them, you can use match or iflet to extract and use. Yep. Alright, in order to provide a well-organized API to your users that is straightforward to use and only exposes exactly what users you need, modules time. Looking at prehistory Rust repo, looks like it didn't support... Yeah, iflet is pretty recent if I recall. Like... Yeah, like... Oh, is it from Clojure? Oh, it's taken... I think it's taken from Clojure. The Rust book in 2019, yeah. Yeah, if it is from... Yeah, like... That's funny, yeah. If it's, like... Web MIT to you, huh? Oh, this is just, like... Yeah. That's just a mirror of the book. Okay, yeah. Yeah, if it's just, like, from... Yeah, like... Makes sense if it's taken from another language, but yeah. Rust, Is there... Yeah. 0160. Iflet, yep. Yeah. RCPR. Yeah. Merged August 2014. So yeah, it's like in like... Yeah. That's RFC for iflet, yeah. Just like trying to figure out which Rust version it got added in. But yeah. Alright, so yeah. Alright, as write large programs, organizing your code will be important because keeping track of your entire program in your head will become impossible. Hooray, complexity. By grouping related functionality and separating code with distinct features, you'll clarify where to find code that implements a particular feature. Yep. It says it's from Swift, huh? Apparently it's from Swift! Whee! Alright, Alright. Oh, but, like, yeah. Alright, yeah, but... So, yeah. Not need... it's... Oh yeah, it's just null unwrapping from Swift, okay. Got it. That's fine. Alright, so programs you've written so far have been in one module in one file. Project Rust, you can organize code by splitting it into multiple modules and then multiple files. Package contain multiple binary crates and optionally one library crate. Okay. Kirby, yep, take your time. Yeah. Package grows, you can extract parts into separate crates that become external depths. Chapter covers all these techniques. For very large projects of a set of interrelated packages that evolve together, Cargo provides workspaces. Chapter 14, okay. I'm glad that there's, like, a thing for, like, a multi-library, like, setup native to Rust. I've had hell with that in Java. Fucking Gradle. In addition to grouping functionality, encapsulating implementation details lets you reuse code at a higher level. Once you've imported an operation, other code can call that code by the code's public interface without knowing how it works. The way you write code defines which parts are public for other code to use and which parts are private impl details that you reserve to write to change. Another way to limit the amount of detail you have to keep in your head. Okay. Related concept is scope. Alright, yep, names and scope. Right, you create scope and change which names are in or out of scope. Can't have two items with the same name and the same scope. Tools are available to resolve name conflicts. Rust has a number of features that allow you to manage your code's organization, including which details are exposed, which are private, and what names are in each scope of your programs. These features, sometimes collectively referred to as the module system, include packages, crates, modules, and views, and paths. Okay. We'll cover all these features, discuss how they interact, and explain how to use them to manage scope. By the end, you should have a solid understanding of the module system and be able to work with scopes like a pro. Alright, yep. Great. A crate is a binary or library. Crate root is a source file that the Rust compiler starts from and makes up the root module of your crate. Right. I need any notes right now. Okay, yeah, so package is one or more crates that provide a set of functionality. Package contains a cargo toml file that describes how to build those crates. Several rules determine what a package can contain. They can contain at most one library crate. Can contain as many binary crates as you'd like, but it must contain at least one crate. Alright. So yeah, when we create a package, yep, we do cargo new. Enter the command, it created a cargo toml, giving us a package. Looking at the contents, there's no mention of source main rs because cargo follows a convention that source main rs is the crate root of a binary crate with the same name as the package. Likewise, cargo knows that if the package directory contains source librs, package contains library crate with the same name as the package, and source librs is the crate root. Cargo passes the crate root files to Rust to build the library binary. Okay. Yep. Here we have yeah. So librs is library crate, and yeah. Here we have a package that only contains source main rs, meaning it only contains a binary crate named my project. Package contains source main rs and source librs. It has two crates, library and binary, both with the same name as the package. Package can have multiple binary crates by placing files in source bin. Each file will be a separate binary crate. Crate will group related functionality together in a scope so the functionality is easy to share between multiple projects. For example, rand provides functionality that generates random numbers. We can use that functionality in our own projects by bringing the rand crate into our project's scope. All the functionality provided by rand is accessible through the crate's name. Keeping a crate's functionality in its own scope clarifies whether a particular functionality is defined in our crate or the rand crate and prevents potential conflicts. For example, rand provides a trait named RNG. We can also define a struct named RNG in our own crate. Because a crate's functionality is namespace, when we add rand as a depth, the compiler isn't confused about what the name RNG refers to. In our crate, it refers to the struct RNG. We would access the RNG trait from the rand crate as rand : RNG. Let's move on. Alright, modules and other parts of the module system, namely paths, allow you to name things. Use keyword, yeah, so paths allow you to name items. Use keyword that brings a path into scope, and the pub keyword to make things public. Also discuss, ooh, it's got import as, yay! External packages and the glob operator. Oh, that's a fucking name. Love that name. Alright. Restaurant industry, yep. So front of house, back of house. I've done that before. Import as good, yeah. Alright. To structure our crate in. Yep. So I'm just gonna make a new file. librs. Alright. Structure our crate in the same way a real restaurant works, so we can organize the functions into nested modules. Okay. Create a new library named restaurant, but yep. Not gonna do that, I'm just gonna use the same project because having to like manage multiple like areas through VS Code just seems like a pain in the ass right now. Okay, yep. So mod front of house, mod hosting, then add to wait list. Then C at table. Then mod serving. Then take order. Then serve order. And fun take payment. Ba-dum. Find a module by starting with the mod keyword and then specify the name of the module, and place curly brackets around the body. Inside modules, we can have other modules, as is the case with the modules hosting and serving. Modules can also hold definitions for other items such as structs, enums, constants, traits, or functions. By using modules, we can group related defs together and name why they're related. Programmers using this code, would have an easier time finding the definitions they wanted to use because they could navigate the code based on the groups rather than having to read through all the defs. Programmers adding new functionality to this code would know where to place the code to keep the program organized. Earlier we mentioned that source main.rs and source lib.rs are called cray roots. The reason for their name is that contents of either of these two files form a module named crate at the root of the crate's module structure known as the module tree. Okay. Yeah, here's our module tree at the moment. Okay. Save you for now. Alright, so this tree shows how some of the modules nest inside one another. Hosting nests inside front of house, yep. Tree also shows that some modules are siblings to each other. Yep, so like add to waitlist at table and hosting and serving. Yep. Alright, to continue, yep. Yeah, child and parent, yeah. Entire module tree rooted under the implicit module name crate. Module tree might remind you of the file system's directory tree on your computer. Yeah. Just like directories in a file system, you use modules to organize your code, and just like files in a directory, we need a way to find them. Paths, okay. So we use a path in the same way we use a path when navigating a file system. Want to call a function, need to know its path. So absolute path starts from the crate root or by using a crate name or a literal crate. Relative path starts from the current module and uses self, super, or an identifier in the current module. Alright. Both absolute and relative paths are followed by one or more identifiers separated by double colons. Alright, so in librs, yeah. If we've got all this, so let's return to the example in zone 1. How do we call the add to waitlist? Them is asking what's the path to add to waitlist. Using 7th and listing 7.3, we simplified our code a bit by removing some of the modules and functions. We'll show two ways to call the add to waitlist functions. Yeah, like right now, all we care about is just calling add to waitlist. So let's just have that. Oh, that's front of house, not front of house. Alright, so two ways to call add to waitlist from new function. Yep, so pub fun eat at restaurant. Yeah, empty block, don't care. Alright, so we've got the absolute path of crate. Not create, crate. Front of housing. Add, or yep, hosting, add to wait list, or no, front of house, yep. Then we've also got front of house, hosting, add to wait list. Alright, yay. Oh, you don't compile, fun. Because hosting is private! Yeah. Note this example won't compile just yet, yep. First time we call add to waitlist function, yep, we use an absolute path, yep, that starts from crate and just goes all the way down. Add to waitlist function defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path. After create, we include each of the successive modules until we make our way to add to waitlist. You can imagine a file system with the same structure. We'd specify, yep, /front of house, /hosting, /add to waitlist, using crate name to start, like using /, yep. Then we can also just, like, start directly without the start /, so front of house, hosting, add to waitlist, yep. Relative. Choosing whether to use relative or absolute path is a decision you'll make based on your project. Should depend on whether you're more likely to move item def code separately from or together with code that uses the item. So, we move FOH and eat a restaurant into a module named Customer Experience. We need to update the absolute path, but the relative path would still be valid if we, yep. However, if we moved Eat at Restaurant separately into a module named Dining, absolute path would stay the same, but the relative path would break. Yep. Our preference is to specify absolute path because it's more likely to move code defs and item calls independently of each other. Alright. Yep. Now, you're not happy because... Oh, yo! Nikki! Hello! Welcome in, everyone! Spiritbound Raid, yeah, it's great to see y'all. S.O. Nikki, Soul. Ooh, playing Tekken 7, how was it, hon? Alright. Yeah, for those of y'all joining in for the first time, hello, I'm Lemma. I am a chubby robot VTuber who both makes and plays games on stream. Tonight, I am learning how to write Rust. A really interesting programming language I've had my eye on for a while. Yeah. Oh, hi, Nikki. Season crew, yeah. 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 Okay, yeah. Started with Guilty Gear, then moved over to Tekken. Fighting games are fun, nice and chaotic, yeah. I wish I could, like, enjoy fighting games more, but I just don't like competitive stuff. Yeah. Alright. Alright, so yeah, right now, we are learning how to do modules and importing and everything. We're angry right now because EO603 mod hosting is private. Yeah, you can always watch me beat up some CPUs, yeah. Error messages say module hosting is private, yep. We have correct paths for hosting and add to waitlist, but Rust won't let us use them. It doesn't have access to the private sections. Modules aren't useful only for organizing your code. They also define Rust's privacy boundary. The line that encapsulates the implementation details external code isn't allowed to know about, call, or rely on. So if you want to make an item like a function struct private, put it in a module. Maybe vibe when I choose to play UFC 4 and throat kick Rusi. Ah, god, fuck yeah. Fuck yeah. Yeah. Alright, so, yep. Putting them in a module makes them private. All items are private by default. Items in a parent module can't use private items outside the child modules, but items in child modules can use the items in their ancestor modules, okay. Reason is that child modules wrap and hide their impl details, but the child modules can see the context in which they're defined. Wow, giving children privacy, what a shocking concept. Yep. To continue with the restaurant metaphor, privacy rules are like, being like back office of a restaurant, yep. Goes on and there's private to restaurant customers, but office managers can see and do everything in the restaurant in which they operate. Rust chose to have the module system function this way so that hiding inner impl details is the default. That way, you know which parts of the inner code you can change without breaking outer code. But you can expose inner parts of child modules code to outer ancestor modules by using the pub keyword. So, pub and pub. Yeah. Oh, actually, we don't. Yeah, if the entire module is public, then that should. Oh, still not yet. Okay, got a pub. Boom. Yeah. Very cool. Yep. Yo, Jude too. Hello. Disgaea. Great to have you here, Jude. Hope you're having a good time. Great to have y'all hanging out. Yeah, I'm probably gonna... Yeah, I might go... how... So, alright. Yeah, there's a bit left in Chapter 7, and... Oh, I think I might do a bit of collections, too. We'll see. But yeah. Alright, so yeah. Code listing in 7.5 still results in an error. Gotta make add to waitlist public, too. I do like that, like, the inspector integration... Like... Yeah. I do like that the inspector integration in, yeah, for Rust and VS Code also, like, tells you the error number, yeah, view problem, yep. Yeah, that's cool. Right, yeah, and it just, like, does, like, yep. Yeah, and, like, it gives you, like, all these squiggles here, and, like, it's basically exactly what the compiler would give you. That's good. Yeah. Yeah. Alright, so make the module public, but... that means the contents are still private. Yeah. Making a module public doesn't make its contents public. It only lets code in its ancestor modules refer to it. Errors in listing 6 say add to waitlist functions private. Thank you for the hydrate non. And posture check. I think you're using the wrong VS Code extension for Rust. Looks like you're using the Rust extension. Oh! Am I? Extensions. Traits. I apparently am. Okay, yeah, I'm just using, like, Rust and not Rust Analyzer. Sure, okay. Got it, yep. Conflict, yep. Got it, I'm gonna go to extensions. Delete the search, I guess, yeah. Then Rust, disable. Reload. Rust is more popular because it's the original Rust Analyzer is much more powerful. Okay. Yeah, so now if I, like, get rid of that and save, now you've got, like, the Analyzer, yep. Ooh. Yeah, and, ooh, now it's got Quick Fix! Woo! Alright. Yep. Ooh, Bwops! Thanks, Non! Gonna stretch. Okay. Thank you for letting me know that. Alright, yeah, then. Add to waitlist is... Yep. Yeah, we've got that. Now the code will compile. Look at the absolute and relative path and double check why adding pub keyword lets us use these paths. Yep. Yep. So crate, then pub mod. Yeah, so front of house, because we're at the same level, is public. Then pub mod hosting makes that public, and then pub fun add to waitlist makes that public. Okay. Alright. Yep. And yeah, we can refer to front of house from eat at restaurant. Yep. Next is hosting module marked with pub. Yep. Add to waitlist is pub. Yeah. Yay. Okay, makes sense. Starting relative paths with super. Alright, we can also construct relative paths that begin in the parent module by using super at the start of the path. Just like starting a file system path with da. Can you change supers? It feels like you should be able to, so yeah. So yeah. Super serve order, yep. And serve order. Then mod back of house. Change supers? Yeah, or no, chain, not change. It's like you can have like multiple calls of super in a row if you want to go at multiple levels. Yeah. Oh yeah, I can, yep. Not surprised. Alright. Curly brackets, not square. Alright, so yeah, then up, then fix incorrect order, cook order, cook order, super serve order, yep. Then cook order, but yeah. So I was sad you can't do that in Java, yeah. Yeah, Java's import stuff is weird. Ooh, now it fades out dead code. Neat. Awesome. Cool. Yeah. Alright. Fix incorrect order, function back house. Yep. Right, create as root, so yeah, we can go up with super, yeah. Yep. We're super, so we'll have fewer places to update code in the future. Alright. We can also use pub to designate structs and enums as public, but there are a few extra details. If we use pub before struct def, we make the struct public, but the structs fields will still be private. We can make each field public or not on a case-by-case basis. Ooh. In listing 7.9, we've defined a public backhouse breakfast struct with public toast field, but a private seasonal fruit field. This model is the case in a restaurant where the customer can pick the type of bread that comes with a meal, but the chef decides which fruit accompanies the meal based on what's in season and in stock. Available fruit changes quickly, so customers can't choose the fruit or even see which fruit they'll get. Okay. Breakfast. Toast. String. Seasonal fruit string. Simple breakfast, pub, fun, summer, toast, and stir to breakfast, return breakfast. Oh, that autofills it for me, nice. And study unit types, I want string from toast. Yeah. Yep, then seasonal fruit. String from peaches. Then we can have a pub, fun, or eat. No, I've got eat at restaurant. Here, yeah. So then we can have let mute meal equals back of house breakfast summer fry meal dot toast equals string from wheat. Print ln I'd like toast please meal toast. Boom. Yeah. Yep, then next line, yeah, then this line is illegal. You can't change the seasonal fruit. That's private. Yeah. Yep, toast in back house breakfast struct is public. Eat a restaurant, we can write and read to the toast field using dots. Can't use seasonal fruit. That's a crime because that's private. Yep. Backhouse breakfast has a private field. Struct needs to provide a public. Whoop. That's 9 o'clock. So the struct needs to provide a public AF that constructs breakfast. Okay, if breakfast didn't have such a function, we couldn't create an instance of breakfast in Eat It Restaurant because we couldn't set the value of the private seasonal fruit field. Okay. By contrast, if we make an enum public, all of its variants are then public just because that's how enums work. You need them all to be public for completeness. Yeah. Yep. Appetizer enum public, we can use soup and salad. Yep. One more situation involving pub we haven't covered. That is use. Cover use by itself first, then show how to combine pub and use. Okay. Yeah, how about, yeah, I'm just gonna, clean up some of this. Yeah. Got pubmod hosting, pubfun add to waitlist, yep. Oh, I didn't cover pubcrate, yeah. Use is pretty much import, yep. Oh, yeah, I haven't seen that before, yeah. Yeah, I'm not, yeah, what does, yeah. What does pubcrate do? Yeah, pubcrate makes it public to only your crate. Yeah. But yeah, I noticed that when, like, I went, you know, on the quick fix, so... Yeah, so that makes it package private, basically, in Java equivalent. So yeah. Yep. And now I can get rid of this, because we're going to replace it. So yeah. And now we can use crate, front of house, hosting, up. Then hosting, add to waitlist, hosting, add to waitlist, hosting, add to waitlist. And we don't need to prefix it every time. Yay! Also pub super and pub in some path. Learned about those 15 minutes ago. Fun! Right, yep. Yeah, then you could also use, yeah. Use and path and scope similar to symlink. Yep, it's just an import statement. Yep. Use in a relative path, so self, front of house hosting, yep. Idiomatic use paths, okay. Might have wondered why you specified use crate, front of house hosting, and then call it hosting add to waitlist and eat at restaurant, then specifying the use path all the way out. We could do that. Listing 711, 13 and accomplish the same task. 711's the idiomatic way to bring a function into scope with use. Bringing the function's parent module into scope with use means we have to specify the parent module when calling the function. So, yeah, basically it gives you more naming room. Specifying the parent module when calling the function makes it clear the function isn't locally defined while still minimizing repetition of the full path. Yep. Code, yeah, it's same reason like you don't, yeah, why you don't import static in Java. Yep. Code and listing 713 is unclear as to where add to waitlist is defined. On the other hand, when bringing in structs, enums, and other items from use, idiomatic to specify the full path. Alright, so structs, enums, and other items you bring in directly. Yep. Makes sense. Yeah. No strong reason, just a convention that's emerged. Folks have even gotten used to reading and writing Rust code in this way, okay? Exception is if we're bringing two items with the same name into scope with use statements. Because Rust doesn't allow that, so yeah. So two result types, you'd use format result and IO result like that. And, there's also, yeah, and the other option is import as, yay. Love import as, TBH. One of the, yeah, like, Java really needs import as, TBH. It really needs import as, God. Because you can't do relative imports, you can only do fully qualified, so yeah, like, you can only pull in a, like, class directly or do a full qualified import. Like, Jesus Christ, why has this not been, like, why has this not been jepped yet? Right. I think they thought it'd be confusing though. Yeah, but like, they should at least have one that's better. Yeah. 905s, yeah. Re-exporting names with pub u. Ooh, alright, so. Yeah, star imports. Yeah. Yeah. Yeah, yeah, bringing a name into scope of the use keyword name available in the new scope is private. Enable code that calls our code to refer to that name as if it had been defined in that code scope. We can combine pub and use. Re-exporting, woo! Alright, that's cool. So yeah, now I can... See, you can pub use that, yeah. That just rescopes it for, yeah. Dependents, woo! If you hadn't specified pub use, eat a restaurant could call hosting add to waitlist in its scope, but external code couldn't take advantage of it. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor... Yep. Yeah, it's cool, no more boilerplate to call the exact same function, yeah. Yep. People running the restaurant think about front of house and back house, but customers visiting a restaurant probably won't think about the parts of the restaurant in those terms. With pub-use, we can write our code in one structure but expose a different. Doing so makes our library well organized for programmers working on the library and programmers calling the library. Okay. Yep, then we've done like imports before, so yeah, like rands, then rand RNG, yep. You do that instead of crate. Alright, yep. Members of the Rust community have made many packages available at crates.io, yep. Standards also crate that's external to our package. Because standard library is shipped with Rust, we don't need to change cargo table to include it, but we do need to refer to it with use to bring items from there into our package's scope. Yep, so standard collections hash map. Ah. Ooh, out of water. Ooh. Surprised lasts like just as long as like the normal 3-hour stream, but yeah. Nested paths clean up large use lists, yep. So yeah, ooh, that's a neat syntax. That's equivalent to Python's from import. Alright, yep. Yeah, that's an interesting one, okay. You can use nested paths to bring the same items into scope on one line. Specify the common part of the path, 2 colons, then curly brackets around the list of parts of paths that differ. Okay. Woo!
Hey all, I hope you are having a great day.
Neelock, thank you very much for subscribing at tier 1 for 10 months! Wow! Thank you. Yeah, I super appreciate it. Yeah, I am having a pretty good day. I'm having a lot of fun learning Rust. I've only found like one syntax weirdness, and it's just a sugar, so I don't have to worry about it. But yeah. Okay. You can use a nested path at any level in a path. Yep, so combine multiple use statements, okay. Now, can you... Yeah, standard self, right? Yep. Now, there's... glob operators is just like import all, okay. Now, here's the question, can you nest these, yeah, can you, like, deep nest paths? So, like... Yeah, like, can you do standard comp, then, like, multiple things after comp? Feels like you should be able to, so yeah. Alright, yep, glob operators also used to bring everything under test into the test module, okay. Yeah. How to write tests in chapter 11, okay. Standard lib doc for more info on the pattern. Got it. Separating modules into different files, yay. Rust is a really satisfying language once you get the hang of it. It's my favorite language, yeah. There's some, like, weird, I don't like if-let. I don't... Yeah, like... I understand where it came from and how it's used and, like, what it means, but it just feels a bit... It's just a bit harder to wrap my mind around it. Wrote out the paths filling my imports because I thought it was clear, yeah. Yeah. Let's start... Alright, so, yep, still in librs, yep. Okay. It's whole root crate, the crate root file is source librs, but procedure also works with binary crates. Crate root is source main rs, okay. Yep, so, yep. Source front of house rs gets the definitions from the body of the front of house modules, yeah, new file, front of house rs, mod hosting, fun add to wait list, and over here. Yeah, then I can just like get rid of this. Oop. Whoops! Thank you, Nikki. Now you are angry because you're not from the crate. Yeah. Yep. So yeah, front of house rs. Yep. Semicolon after mod front of house rather than using a block. Tells. All right. So. in librs we want mod front of house. There. Using semicolon after mod front of house rather than using a block tells Rust to load the contents of the module from another file with the same name as the module. To continue with our example, extract the hosting module into its own file as well. Yep. Yeah, then we can, yep. So yeah, then we can new file front of house hosting rs. Ah! Why am I not good at hitting the H key tonight? Same, yeah, that's twice I've made that typo now, so yeah, yeah, now you can just, like, hosting, you know, not pub, alright, there. Then submod hosting, yep. Why are you angry, actually? Oh, oh, because you don't have the extra hosting module there, okay, yeah. Alright, there. Now you're happy, okay. Forgot about that, yeah. Okay. Module tree remains the same, and function calls needed at restaurant will work without any modification, even though the definitions live in different files. Lets you move modules to new files as they grow in size. Okay. Hub use create front a house hosting statement in source librs also hasn't changed, nor does use have any impact on what files are compiled as part of the create. Okay. Mod keyword declares modules, and Rust looks in a file with the same name as the module for the code that goes into that module. Alright, summary. Rust lets you split a package into multiple crates and a crate into modules so you can refer to items defined in one module from another. You can do this by specifying absolute or relative paths. These paths can be brought into scope with use. Yep. Module code is private by default, but you can make definitions public by adding pub. In the next chapter, we'll look at some collection data structures in the standard lib that you can use in your neatly organized code. Okay, 913, alright. I've gotten, 3 chapters done tonight. I think I'm gonna wrap up for now. My throat's getting a bit sore, but yeah. For now, let's tag back over. Yeah. I'm having fun with Rust. It's super interesting. Yeah. Yeah, I'm enjoying it a lot. It's like, it's really getting, like, it's really actually helping me think about, like, programming, like, how programming languages and computers work at a more fundamental level, and that's really cool and makes me really happy. So yeah. Yeah, it's neat. I like it a lot. I am excited to learn more. Yeah, I'm still not sure if I'm gonna make anything in Rust, but I definitely would like to at some point. Like, there are, like, up-to-date Rust bindings for Godot, so I could use it there. Tons of different things I could do, so yeah. Yeah, there's like a raid! Alright, lots of folks live tonight. Yeah. Anyone got, like, recommendations who to raid? There's so many people live at the moment. Yeah, if you have any recs, let me know. Otherwise, I can just pick someone. What have I got coming up rest of the week again? I keep forgetting my schedule. Like, I set that thing last night. Why do I keep forgetting it? Alright, so, yeah, tomorrow's Loop Hero. Sunday's gonna be an Outcry. Monday, It's gonna be Valhalla. Yeah, this is gonna be a pretty fun week. Not much programming, but still gonna be cool. Very excited for it. Okay. Yeah, I think I'm gonna find someone to, what have they been going, couple hours? Yeah, how about... Yeah, ooh, they seem more... Yeah, I think I'll go over to them. Okay, yeah. Alright, we are gonna head over... Alright, so we're gonna go with a soft Robo Raid tonight, and then throw Hug on it. If you don't have the emote, you can unlock it for just 150 channel points. We're going to raid Neon Pixel tonight. Thank you all so very much for watching, hanging out, joining in. I've had a lot of fun. I can't wait to learn more Rust, maybe make some projects in it. But yeah, this is gonna be a pretty packed week. I am not feeling fucked up from COVID at all, which is a really good thing. Yeah, I've managed to like just stay completely safe so far. I've got a test. Yeah, I did a test today, so we'll see if I've actually got it or not. But yeah, when we get over Neon Pixels, please don't forget to drop them a follow there. Pretty cool. But yeah, with that, I'm tired, so I am gonna finish up. How about we get this raid started in 5, 4, 3, 2, 1. See you soon!